Welcome to the Sophistic online documentation. This tutorial focuses on footfall analysis of floors. Specifically, the first step of the workflow, modeling the floor subsystem using Revit and Sophistic analysis and design. We will start with a model from the reinforced concrete building seismic analysis tutorial. This is a high-rise building with multiple stories above the ground. For this detailed structural analysis check, we will extract a floor subsystem from one of the lower stories of the high-rise building. To ensure realistic boundary conditions, it is recommended to include the adjacent columns and walls into the floor subsystem. The usual subsystem workflow cannot be applied for a detailed check, since we will manipulate a multitude of properties which would interfere with the classical design workflow. Therefore, instead of cutting a subsystem out of the main system, we will copy all relevant structural elements and paste them next to the tower and create there a subsystem out of them. With this method, we can stay inside the BIM model and still perform the detailed check. Alternatively, it is also possible to export the adapted model in an extra file and perform the detailed check in a separate place. To begin with, we apply the AMG view template to have a better visualization of the analytical model. We go to View, View Templates, and select Sophistic AMG 3D. Furthermore, we deactivate the visibility of the physical model. Now, we select our desired elements and filter out the wind loads, which are line loads and are not of relevance for the footfall analysis, and also the levels. Next, we go into the top view and copy our selected elements next to the tower. In order to create a subsystem, make sure the main system was calculated once before. Sophistic needs this elementary information which elements are connected to each other. Therefore, we go to Sophistic Analysis and Design and open the structural properties. It's not necessary to calculate the center of rigidity, as well as analyzing and applying the loads. Now we calculate. Next, we can select our elements and click on Subsystem View. We call the subsystem Footfall Analysis. Our primary focus is the vibration analysis of the floor, which is modeled using analytical panels, same as the adjacent walls. The columns are modeled using analytical members with an assigned cross-section. The floor is divided into two zones, an hallway area as well as an office area. Both will be assigned a specific group number. For the hallway area, we will use the group number 10. Therefore, we select the panel, go to the Sophistic Structural Properties, and edit the group number to 10. To assign the group number of the office area, we will use an attribute area. First, we go to Analyze and create a new panel. We click on Panel by Boundary, select a work plane, and draw the contour lines. Please take care not to draw in one turn over the walls here, but to split the line. Later, we will need to place boundary conditions which are not desired in the wall area. Next, we go back to Sophistic Analysis and Design and click on Convert to Attribute Area. This allows us to override the group number inside of this panel for the office area. We choose the group number 20. All other properties, like thickness, will be untouched. For the concrete model used for the floor, the Young's modulus needs to be increased for the fact that concrete exhibits higher stiffness under small strains and short-time dynamic loading. than what it's typically assumed in static design. To correct this, we will create a new Revit concrete material and assign it to the slab. In order to do so, we select the slab, go to Properties, and open the material browser. Now we just copy the existing material and rename it to Footfall Analysis. Please take care that also the physical material is copied into a new entry. We do now see in the properties that the new material, Footfall Analysis, is assigned as well as the new physical material asset. Now we take a look at the material mapping. We find the just created Revit material, which is right now mapped to the standard Sophistic concrete material. Once again, we will create a new material. We call it Footfall Analysis. Choose 30 for a classification, and now just manipulate the Young's modulus to the higher value. Next, we create the boundary conditions. We opened the section of Analyze and choose Boundary Condition for points. The same we do for the walls. The boundary conditions are defined that the ends of the columns and walls are fixed. Additionally, assuming the presence of a facade, we will apply pinned vertical supports around the perimeter of the building. Please take care not to place the pinned supports at the walls. The load from the main system is already carried over and can be left untouched. This includes an additional live load as well as a dead load assigned to the floor. The original main model has hinge connections at the top and bottom of the columns. We are reverting these by selecting the columns and choosing Fixed for both ends. We can now calculate the subsystem and export the model to the Sophistic Structural Desktop. The resulting finite element model consists of quad elements for the slab and the walls and beam elements for the columns. In the next video, we will continue the Footfall analysis workflow in the SSD. Thank you for your attention.